All right, so we're back with more coding content. And let's continue setting up the repo. So very clean Python. We're not, we don't have anything yet that actually implements anything functional, but we'll get to that. Don't worry, it's gonna be pretty fast. Last time we ended up on this branch with pre-commit hooks, right? So we did a lot of work on sort of setting up these pre-commit hooks, and let's see what's happening here. I wonder, is this okay? We don't know what that is. Interesting. Okay, so then what we want to do now today is sort of continue the work we started last time, and let's add more hooks. And we already added a branch commit one, and we're on the same branch. We're on the branch where we left off, which is more pre-commit hooks. Let's add something that's outside of this repo now. Now we're gonna talk about automatically formatting the code using Ruff, because if you remember, we used to do UVX Ruff format -- line length 108, and this does all the thing where it installs Ruff and it reformats the code. If it would have been longer, it would have split it. But we actually want our pre-commit hook to do this for us, right? We want to check formatting before we commit and automatically apply fixes. So here's how we do it. We go, we just search on Google, right? And we search for Ruff pre-commit hook, okay? And before we do that, we can also take a quick look at sort of what the plan is, right? So last time we did UV and PyProject TOML. Those are done. We have them in our GitHub repo. Now we're sort of in the middle of this pre-commit hook task, and we want to add more hooks for formatting, and we want to add one for typing, which is going to be very, very important. Then after this one, we can actually start writing some code and add more dependencies. So let's continue with the Ruff pre-commit hook though. Now, here we go on the official Ruff website from Astral. Bingo, this is what you have to do. Just add this to the repo. Oh, and there we go, args fix. Okay. So we want Ruff check to also, we want the linter to also fix our code. And we just copy this and we add it as a new repo here. Now, what I don't like is that the spacing is inconsistent here. So let's make it consistent. 2. 4 is fine, just 1, right? Yeah. There we go. So now we added Ruff version 0.14.14. And now if we run UV run pre-commit run all is shorthand for all files, I think. Oh, there we go. We have a bunch of changes already. Oh, and then the file fixer and the mix line ending, which are fixed. Actually, nothing on Python. But now, what if we actually start to do some Python code here? Let's say we define a function. A lot of arguments for we can't name to this function that spill over many lines. Okay, so let's say we have this function and it returns true always. Okay, so now Ruff, what we want to do is we want to run Ruff. Now there's another thing though, we need to configure Ruff. Remember, we like to do, so what if we do now, We like to do UVX rough format minus line length 108. Is it even going to do anything to this function? Yes, it does do something, right? Well, let's make this that equals 0, spill equals 23, over equals 55, many equals 66, lines equals 1000. Okay, now if I run rough format, interesting, it still fits. Okay, let's run it with 96 then. Okay, there we go. So it split it, right? Because this did not fit. Actually, we're gonna run with 96. We're gonna be a bit tighter with lines, right? Because we want to see this nicely on screen. So what happened is this automatically formatted our code to fit in 96, but we want the pre-commit hook to do this. But we don't have a line length parameter for Ruff. So how does it know? The answer is, in the official Ruff docs, you can specify Ruff parameters in the PyProject, which is really nice. This is why PyProject is very important, because it not only contains dependencies, but you know, it contains, all right, so let's see, the Ruff linter, configuring Ruff, here we go. So there's a section called tool.ruff, which we need to add, okay? And if we leave it unspecified, this is the configuration that runs behind the scenes. So it runs with line length 988 and indent width 4, which is a bit strict. We want to change this line length to be 96. And that's it. Now, if I run, I don't need to run, we're not gonna run UVX anymore. If I just do UV run pre-commit run all. Okay, there we go. Ruff now runs together with all the other hooks, right? And that is it. Now, if I add a comma here, then that's an indicator for Python that I want these, there we go, spilled all over many lines. But we don't really, if I remove the comma, then Ruff picks that up and reforms the code in a single line. To be honest, code like this really does look better spilled over many lines. But we don't really care about any of this, right? Because this is just a dummy function. So let's remove it and let's add the Ruff hook now. So git status. So we changed PyProject because we configured Ruff and the pre-commit config YAML. Add Ruff hook. There we go. So we can push to our branch. Okay, so now we have automatic code formatting. Again, we don't really see the impact yet, but we will see it once we start writing more code, because we haven't written any code at all. Okay, but that's coming, don't worry. That is coming relatively soon. Let's see, what else do we have planned now? So we're finished. Actually, let's take a look at Ruff. Are there any other interesting arguments? Yes, we want to exclude all of these. We trust the UV devs or the Astral devs. Allow fix for all enable rules. Yes, we want to fix everything. Allow fix for all enabled rules when fix is provided. Okay. Oh, so you can exclude some from fix. Use double quotes for strings, I guess, if indent with spaces. Yes, this is very important. Python code should be indented with spaces, not tab characters. So Ruff takes care of that for now. True for us. Takes care of that for us too. Okay, pretty clean, pretty clean. I don't think we want any specialized things. Okay, so we got the hook, we got the fix. Any other pre-commit hooks? Let's go back to the basic pre-commit hooks. I don't think so, right? We have the main branch protection. Private keys, we're not gonna do private keys. No commit to branch on main. Pretty format JSON. We're not gonna work with JSON files. We don't have requirements txt. Sort simple YAML, no. Oh, trailing white space. Oh, we have this. Sorry. This is a default hook. Okay, that's it. Okay, so back to the drawing board. So we're pretty much done with the default pre-commit hooks. We're ready to write Python code now. Let's get into a PyTorch side. Okay, so let's well, actually, before we do that, let's merge this branch. Okay, remember, because we don't want to get, you can always keep working with many local branches, but it's good to merge them every once in a while so you're back on main and you can check something else off of main. So let's go to our repo. For that I have to switch to Firefox, which is fine. Let's see here. So okay, so now we have our repo, and if you refresh the page on a repo you just pushed to, it kind of tells you, oh, look, this branch had recent pushes 3 minutes ago. Okay, so then what you do is the most basic thing, we're going to open a PR for each branch, and you give it a nice title, add more pre-commit hook, and just a nice description, adds more pre-commit hooks from, and let's document what we did. One of them is Ruff, and the other one is the default repo, I believe, right? Pre-commit hooks. So from this repo. And let's also put a link to Ruff, I guess, so we know where it is. Okay, and no, we don't want this, we want it like this. So then you just do create pull requests. Now there's not going to be a reviewer here because it's just me, but before that we always want to squash and merge, because we don't want to have these intermediate commits appear on our main branch, right? If I just do a merge here, I'm gonna suddenly have 3 commits appear on the main branch, and I kind of don't like that, because sometimes we may work with tens of commits on a pull request. We don't want to pollute our main branch history, right? That's it. And we can delete this branch. And no more pull requests, and now the files that are changed landed on main. So that's it. That's what I'm not going to show how I do all these every time, but this is pretty much the basics of merging branches in a GitHub repo. Okay, all right, so now we can come back to our code here, and we finished adding the pre-commit hooks. Let's move on. Let's look at, see, what do we have here? Well, okay, so we added more pre-commit hooks. I think it's time we can start dealing with a bit of PyTorch, right? So let's actually add PyTorch, which will be added to the project.toml. And let's implement our first function, right? Because it's time to move away from this sort of toy main here. And let's do it. And actually, let's start implementing signal processing from the paper too, right? Because remember, the goal is to sort of re-implement this paper of mine, and let's do the most basic thing in PyTorch, but with the GPU. And we'll use the UV instructions to add the PyTorch, and we'll basically run our first code on the GPU, which is this basic equation. Okay, so in this paper, bold uppercase letters, they signify matrices, and bold lowercase letters signify vectors, right? So then this equation is a matrix multiplication, H matrix multiplied with P, plus another matrix N. And the shapes must be correct, right? Because in linear algebra, if we we can do a small drawing here. So we're gonna have to multiply a matrix, let's say, of this shape with a matrix of this shape, right? And that gives us, well, these are way too large actually. Let me make them smaller, right? So what do I need here? I need the number of rows to be equal roughly to the number of columns. So something like this. And this gives us, the result of this is a matrix which has the same rows as the first matrix and the same number of columns, which is something like this, as the second matrix, right? Roughly speaking. Yeah, we can align this. Ta-dam, and ta-dam. Okay. So this is a matrix multiply, right? So this is gonna be our H, this is gonna be our P. This is an intermediate result. Then we're gonna do an add, which is just a matrix plus with something of the same shape, which is our N. So this will be HP plus N, and this gives us our Y. And that's it, right? So we can then take this further and we can say our Y also has the same shape as these other ones, okay? And that's it, right? This is what we want to implement, which is pretty basic. And let's do it on GPU with random data too. Now, so this will be a, hang on, we can do this better. This will be a matrix multiplication, and we're gonna do this with torch.matmul. This is just matrix addition. It's just a plus operator, right? So it's just plus in Python. And that's it. That's the result from the paper. Okay, so let's get to it. Now, before that, we need to install PyTorch, right? And what I like to do is, first I look at the official instructions, right? So install PyTorch. And let's see what the latest, okay, so PyTorch is on version 2.10, which is pretty nice. And for Windows with pip, we're gonna use UV though, we know that, but I just like to look at the version. CUDA 12.6 sounds fine. CUDA 12.8 maybe. Yeah, let's do CUDA 12.8. We could even do CUDA 13, but maybe it's too bleeding edge. So let's install PyTorch with CUDA 12.8. Now we need to look at UV a bit, because UV has, because it's so popular, it helps you install PyTorch, which is really good from UV's part to include docs like this. So, so first we're gonna do UV add PyTorch, right? Are we on a branch? No, we're not on a branch. So we wanna check out the branch, because remember, our pre-commit hook is gonna force us to work on a branch. So we're gonna check off a branch called add PyTorch. And let's do UV add torch 210 0. Okay. Now it's gonna add it, but it won't add it for GPU, because actually let's reorder these a bit. Whoops. Yeah, these look pretty ugly, but we'll have to reorder them. So now PyTorch has special instruction. Well, UV has special instructions where they try to help you. There we go. So we need to specify we want this from the index CUDA 12.8. Otherwise, it just installs it on CPU by default. Okay. And then we also need to specify the tool source for this torch package to be CUDA 12.8. So we need 2 more sections. But again, the UV explains everything, which is really nice. Okay. So we're gonna have PyTorch. Okay, we'll take this as is, sure. And let's add the index tool, like they say here. Let's see. After, let's rearrange these a bit. So dependency groups should be after dependencies, obviously. I believe build system is the last one and tools are after. Yeah, this looks way better, right? Yeah. Okay. Tool Ruff, build system, dependency groups. Okay, so now if I magically do UV sync, okay, now it's actually downloading PyTorch 2.10 with CUDA 12.8. This is gonna take a while, but this is it, right? In the meantime, we can start writing some real PyTorch code. And the first thing you want to do is, obviously, we're going to have to import torch. And remember, we want to do matrix multiplication, right? So let's do it directly on main, okay? And remember, we need H. We're going to do torch.randn. Now, we need sizes for the matrices, right? So for our paper and in wireless, the left side of H is called number of receivers. The right side of H is called number of transmitters, which is also the left side of P, and number of pilots is the third side, the right side of P. We'll just give these some sizes: 64, 32, 16. Okay. So torch.randn. Remember, these are also complex valued, right? So num_rx, num_tx, D type, very important, is torch.complex64. Oh, and we need to specify the device, right? So let's actually make sure this runs on GPU, CUDA 0, okay? Device. P is also a random matrix, but with appropriate sizes. Remember, we're not gonna be able to multiply if the sizes are incorrect. Torch complex 64 device. And is also a matrix with also the right sizes, so it's num_rx and num_pilots. And finally, we can say y. The function is just torch matmul, right? So it's really trivial. H, P plus n. That's it, okay? So so we added, let's see. So first, let's add PyProject and UV lock. And we're going to git commit add PyTorch dependency. Okay, this worked. Now let's add the main. src MIMO main. Which commit add matrix multiply code equation 2 from paper. We already implemented that. I mean, of course, this is not okay. Now, interestingly, what do we see here? So the linter kicked in, fixed on spacing, but because we use Ruff, it's actually warning us that we have an unused variable y, and it will not let us commit this code, because this is what real Python code should look like. You should not commit code where variables just go nowhere. So just for that, we're going to make this return y. So now we have to add it again. src, because remember, the hook changes the file, and then if we try to commit again, we should, okay, there we go, we're good now. Okay, git push, we need to create the branch, so we're gonna do add PyTorch on the upstream, and that's it. Now let's see if the code magically runs. It really should. UV run MIMO.main. Okay, UV takes care of everything. Failed to initialize numpy. This is just a warning though, right? This code actually runs. Interesting. This is not an error. This may be PyTorch's fault. Yeah, the code runs. So we have, okay, so we have h.shape 6432, p.shape. So when you multiply these h times p, the matrix is 6416, n should be that shape obviously, and y is that shape obviously. We can do torch is or all close. Let's see, is this a function? Yes. So let's see, obviously this is correct because we're just repeating the same operation again, but sometimes it's good to, it's good to sanity check. Are they complex values? Yes, they are complex values. What does torch.randn do for complex numbers? A good thing. When I was a lot younger, I actually contributed, I raised an issue with PyTorch docs because it has a bit of undefined behavior. If you sample a random Gaussian, so here's one. So h real would be torch.randn numRx, numtx, dtype, torch.float32. So this will be a real valued matrix, okay? What is the standard deviation of it? It's approximately 1, okay? What is the standard deviation of the complex valued matrix? It's also 1, but if I look at the real part only, oh, here we go. It's actually 1 over square root of 2, right? 1 over torch dot square root of 2, torch tensor 2. Yeah, it's approximately 1 over square root of 2. So this is actually correct. This is called a complex unit Gaussian. So a complex unit Gaussian is a bit different than real value Gaussian, where the standard deviation is 1. For a complex Gaussian random variable with unit power, it doesn't mean that the real and imaginary parts both have a power of 1. They have a power of 1 over square root of 2. So then when you square those standard deviations, they become 1 over 2 plus 1 over 2, and you add them, because you add the power from the real and imaginary parts, that is 1. So you gotta be careful when sampling complex random numbers in PyTorch, because they are correctly sampled. So a naive thing to do is to say this is 1 over... oh yeah, do we not have NumPy, actually? Okay, so that's why that warning, interesting. So let's add UV add NumPy. This is PyTorch's fault, but then UV helps us, and I like to pin these down. So actually it's 242. There we go. So now I can do import NumPy as np. A very, very wrong thing to do is to do this is 1 over NumPy square root of 2 times this. This works. Not score MIMO.main, but it is bad because this is no longer unit powered. This is sub-powered now, because the real imaginary parts are not unit powered by themselves in PyTorch. They're 1 over square root 2 powered. Okay, so long story short, this is the correct way to sample a complex Gaussian. What did I do here? Add explicit NumPy. We're gonna need NumPy. Okay, so that's it. Okay, so I think this is pretty good. This is a good sort of stopping point, because we added PyTorch and we actually ran code on GPU, mind you, very easy, and we actually implemented a small part of our paper, which is this matrix multiplication and addition with noise. Funny enough, this is actually the equation that we're going to try to solve, right? What our paper does is, loosely speaking, is you observe y and you know p, and you need to recover h. So it's kind of similar to matrix inversion, but it's from fewer observations. So it's like sort of trying to solve this impossible matrix inversion. But from a code point of view, we used UV with PyTorch. So let's see, we made a lot of progress then on the PyTorch task and a bit on signal processing task, PyProject. The hooks helped us because we saw they won't let us commit dangling random variables. You know, in all honesty, we're pretty close to AI here. We have PyTorch running on GPU now. All we need is to install a model library. We pick a model, and then we're very close to diffusion, but we'll see how that goes next time. Yeah, so thank you for joining. Thanks for watching. Don't forget to like and subscribe to the channel. Leave comments if there's still questions or questions about anything. This is all going to be on the repo. I'll do the merge myself on main. But yeah, thanks for watching. This was pretty good, and we're making good progress. So we'll see you next time.